Hello and welcome once again for another example problem. So here we have a slope field, in this case done in Sage Math. So if I circle this here, this is done on Windows in Sage Math, and basically very simple to learn. Coding is just like Python. And the differential equation here is y prime equal to e to the x plus y. Okay, and so substituting this into Sage Math, first you have to get variables. So and then fortunately, Sage Math has a very simple method called plot underscore slope field plot underscore slope underscore field, where you simply substitute in the right hand side of the equation. So this e to the x plus y goes in the first term. The second one tells it where to plot, what range to plot over x, and the third one tells it what range to plot over y. Now we can actually verify that the slope field here makes sense by looking at the values of what it should be over here. So it's easier for obviously smaller values. So let's say x equal to 0, y equal to 0 as an example. Well, if x is equal to 0, then e to the x is 1, right? E to the 0 power becomes 1, and y is 0. So this just becomes y prime is equal to 1 in that case. Oops. So that tells us the slope should be about 1 if I go to 0, 0. Which it appears to be the case, that if you look at these lines right here, they're pretty close to a slope of 1, right? So this makes sense. Now let's pick another spot just to verify. So let's do x equal to 0, y equal to 1. And again, in that case, this is not e to the x plus y, it's e to the x minus y. My apologies. I wrote this wrong here. E to the x minus y. As you can see, it's e to the x minus y inside of there. So e to the x minus y. So if that's the case, well, again, e to the 0 is 1, and then y is also given as 1. So 1 minus 1, my y prime should be equal to 0. So I should have a flat slope at 0, 1. So if I go up here, let's map out where 1 is. Somewhere in, right about here. And notice that, like right about here, you can see that it's very close to being perfectly flat, as it should be. If I hit it right on that point, the slope would be 0, right? So this verifies for us that this in fact is a reasonable slope field or vector field, if you want, for this particular equation. That's all that I have for this video. See you again soon.